Okay, good afternoon, everyone. Today we're going to continue our discussion on portfolio optimization, which is a fundamental topic in finance. We started discussing this last time, and we said that there are some powerful packages that are used in in finance in modeling portfolios. Uh, an example of that package is quant mode. There's also this tidy quant, performance analytics, and these packages we're going to make use of as we go along. And last time we learned that quant mode is a very powerful package for acquiring data sets, managing your data, creating charts, and for technical analysis. We learned how to, for example, use quant mode, in particular the get symbols package. The quant mode package, in particular the get symbols function, to download stock prices from the web, in particular Yahoo Finance. Okay, so this was what we did last time. I won't repeat that. Okay, uh, then we can also make use of the quant mode package to plot your data set. We learned, of course, to use the plot function from base R. We learned also the multi-dot panel plot. This is used if you have your data with several columns. We can make use of this. Okay. And what we learned last time was when we plot your object, which we generated from quant mode, which consists of the OHLC, open, high, low, close, the volume and the adjusted price. This will not give us a good plot because one of the variables there, the volume, okay, you can see here the volume, since it's not in the, on the same scale as your prices. Okay, then you can see here that the uh, the plot of the volume is more pronounced than the plot of the prices open, high, low, close, because the open, high, low, close are relatively a lot smaller than the volume. So what we can do with this one, what we did last time was to remove the fifth column, which is the volume, and then just plot the. So here I'm creating this object Apple1 where the fifth column, which is the volume, is deleted. Okay, and then I can now plot Apple1 there. And more or less the the plots of the OHLC are better seen here. Or you can use the plot function and just use the plot Apple1 so that the plots are in the same axis, in the same starting point, and you can see here some of the differences. Okay, right, then we also learned how to make use of the chart series function in quant mode, which will give us a plot where the volume is plotted separately. Okay, you can see that the volume, since it has a different scale, it's separated from the other prices. Okay, and this one makes use of the open, high, low, close data. All right, so what we learned last time also was to work with a function called lapply. The lapply will allow us to download the stock prices of your chosen stocks, chosen assets. In this case, Apple, Google, Microsoft. This is Facebook, Tesla, and Standard and Poor's 500. We created an object containing the ticker symbols of these assets. Okay, and then, okay, may message lang si Cristiano dito, no? For those of you who want to join their group, kindly do so. All right. So, and then we use the lapply function. This will create a list of the tickers. We have identified the tickers, and then we're identifying the function using the get symbols, starting date, ending date, periodicity is daily, and then auto data assign is equal to false. Okay, if we run this, I'm going to run this. Okay, this is just a quick review class. So we can see here that the my stocks here, it's a list because of the use of the lapply. And then take note, the subsets are 1, 2, 3, 4, 5, 6, 7, 8, 9. It's subset number 1 contains 4,028 observations of 6 columns. So this is your OHLC. Okay, OHLC. So let's try to see if we get the, let's see if this will work, names of, let's see, under my stocks, my stocks, and then let's get the first items here. Item here, my stocks, which is this one, it's a list. And then we're getting the names of this object under my stocks, the first subset here. Okay, let's see. All right, so we're correct. We know that this contains Apple. Since this is the first object, it will give us the open, high, low, close, the volume, and the adjusted price of Apple. Okay, so that's what is contained here in my stocks. You can, of course, if we do the head function, head of my stocks, and just get the, that's the first element, which is this one, right? This is Apple. It will give us there the first 6 elements of the open, high, low, close, volume, and adjusted. Okay, so that's how we access any data coming from a list. Okay, so this is this refers to the first object under our list. Remember, our list, a list object can contain different types of data structures. Okay. All right. Any questions so far, class? Is that clear? Okay, no questions. Let me just. Okay. Any questions, class? Could you kindly chat, please? Yes or no, if you got this. Okay. How about the others, class? Okay. All right. Thank you so much. Okay. Now, of course, we can change the name of the items in your list because the names are just 1, 2, 3, 4 up to 9. Here, I'm using this function names of our my stocks object, and we're replacing, instead of just 1, 2, 3 up to 9, I'm replacing it by the name of the stock itself. If I run this, okay, so where's my stocks? Okay, here, let me print it there. Okay, we were able to change the name. All right, so okay, now what we want is for portfolio optimization, we would want to have a data frame consisting of all the adjusted prices and then the returns. Because in portfolio optimization, what we model is the returns of the assets. So we're going to make use of the adjusted price of the asset. So how are we going to create a data frame, an XTS object of the assets? Okay, so here we're creating, we discussed this last time, right? So this is just a quick review. we're creating this object, adjusted prices, and we're also applying, we would want to create a list of what? Coming from my stocks, and then just get the adjusted prices. Remember that my stocks is a list consisting of 9 assets, and we would just want to extract the adjusted price out of that. This is the function add, okay? And we're using lapply. So once again, if we ran this, we ran this last time, and it generated, again, since we're using the lapply, it will generate a list. No? And since the source is also a list, but this time, take note, it's now, the first item here is Apple, and it's a double, it's a quantitative data. Same observations, 4,028, but this time it's just the first column. It's just times 1. So this is the adjusted price. And let's check. So my stocks, okay, let's see. What will be the names of my stocks? No, not my stocks, but rather the adjusted prices. This is now our object, adjusted prices. And then we need this one, Apple. So let's get the bracket of AAPL. All right. So what are the names in this object, adjusted prices? List in particular the Apple object here. Okay, error. Okay, what's my mali ko dito? Okay, wait. Okay. So I'm not having now 2 levels. I'll just use 1 level. Let me see. Okay, there. Okay, it's still wrong, I think. Sorry about that. Okay. Adjusted price, it's a list. I want to get the first item there, the names. Yeah, but kasi, yeah, ang sabi ni Jerome, you use the dollar sign. Yeah, you can use that, but I was in particular referring to this subset, no? If we use, okay, pag ginamit natin, kasi if you get the class, let's get the class of adjusted prices. Adjusted prices, no? The class, this one is still a list. Okay, pag list kasi class, if you're using a list, when you subset, you use the brackets, no? Okay, usually you use the brackets, but as suggested nga by Jerome, so let's get the names and then adjusted prices. Okay, adjusted, okay, prices. And then if you use dollar, okay, pwede rin naman to, no? But I was, I wanted to use the brackets, no? Kasi yun ang subsetting that we use when we're dealing with list. But we can of course use the dollar sign. Okay, here. And then we can get here the name, which is apple.adjusted. Okay. All right. So we know that what's inside here, I just wanted to check if indeed this contains the adjusted prices. All right. So let's continue, class. So we learned how to make use of the lapply. Later on, we will try to see another way to do this because lapply has its own advantage, but there are other functions that are better used instead of the lapply. So what do we do now? We want to generate an object that contains the adjusted prices of all your assets, okay? Of all your assets from the adjusted prices. The assets in your or the elements of your adjusted prices are this. Okay. So what we can do is to merge all of these elements here, because these elements contain one column. So if we're going to merge all of them, we use the do that call and then in particular, what function? The merge function. We did this last time, so let me just quickly run this. Okay, so we now have the adjusted prices of your 9 assets there. Okay, the head function will give us the first 6 elements, and then your adjusted price is a list. However, itong prices natin class, this object that we created, which is a merging of the adjusted prices. Okay, remember the adjusted prices consist of, it's a list containing the adjusted prices of all your assets. When we merge them, it becomes now an XTS or a zoo object. Okay, and then if I print the prices object, there you go. So you have your XTS object here. The index is your date. Then you have your columns, the adjusted prices for all of this. Okay, now why do we need this object? Because it's what we're going to use when we excuse me, class. It's what we're going to use when we compute for the portfolio returns. These are your asset returns. Okay. Let me pause for a while. Any questions so far, class? This is just a review of what we have done so far. Any questions? No questions? All right. Okay, thank you. Now, you notice that we have here a Meta, which is Facebook, and Tesla, containing NA values, which means we were not able to download the prices from 2007, January 3. But they have prices on the other dates. So what we're going to do is to redo the process. Okay, let's repeat the process. Same ticker symbol, same L apply, but this time let's change the date. Or you can actually, what we could have done was to create the prices object where we just subset from the date from 2015-01-01. Okay, but I'll leave that to you as an exercise. Here, I'm just redoing what we did. Okay, everything here. Create this object MyStocks, which will supersede or overwrite the initial MyStocks object that we have already. Where's that? Here, MyStocks. This time, our MyStocks will be again a list, but this time it's from 2015. So this will now overwrite the initial MyStocks. And then let's continue with the process. We're going now to create this adjusted prices. The same thing. Use the lapply function, get the adjusted prices, and then merge them. Okay, and when we run this time the merge data set is from 2015, 01, 02, and then there are no more missing values in our data set. Okay, I'm going through this very quickly because we have already done this in the past session. All right, any questions so far? Are we clear? Okay, no questions? Okay, reviewing will not harm us, class. All right, good. Then we said that quant mode has functions where we can compute for the returns, daily, weekly, etc., even all the returns. Okay, and then we looked at the syntax. And then here, let's use this univariate data Apple. Okay, we created this object before, right? Apple, and Apple contains this one. Apple contains our open, high, low, close. Okay, but we can make use of the adjusted price. Okay, so this function computes for the daily returns from your Apple object, in particular the adjusted price, and then the type is equal to log. Okay, so if I run this function, we now have this Apple returns. It's also an XTS object. And then we have now the daily log returns. Okay, so these are your daily log returns. And the first item here contains a 0 because it's the same as NA because it does not have the previous data wherewith to compute the returns of this date. Okay, so what we do is we have to remove that, diba? We have to remove that because Apple returns, so that's an NA. Okay, so we remove that by just subsetting it, okay, getting the -1. Okay, all right. So that now becomes Apple returns. There's no more missing value there, NA value. Okay, then we can make use of the all returns function. The all returns function will give us the daily, monthly, weekly, etc. So same thing here. I created this object all returns one. Okay, and the function is not daily returns but all returns. Same thing. I'm using the Apple adjusted price type is equal to log, and then if I run this, then you can see now Apple returns one. Let me just print this. Okay, you have so many missing values here because for weekly, it will just compute for the week on week data. Okay, so for example, this is January 6 and this is January 13. It has a 7-day interval. So that's for the 1 week interval. Okay, so that's your weekly returns. On the other hand, the monthly, so this will be end of the month for each. That was February 28, and this is March 31, okay, etc. So that's for your monthly return. And then of course for your quarterly returns, it will be end of March, end of June. So this is end of March return, and then end of June. This is the end of June there, 6:30, okay. And then of course end of September, there, September 29. And then of course end of December 31. Okay, there. Quarterly. And then of course we have the yearly. So this is for 2017, etc. You'll have one data. Okay, again, let me pause and ask you if there are any questions about this before we go on to the next to the lesson that we haven't discussed in the past. Chat, please, class. Is there any questions, or are we clear so far as the returns is concerned? It's important, class, for us to know by heart how to compute for the returns, because when we're dealing with, let's say, portfolio analysis, you're not going to analyze the stock prices. You're going to look at the returns. Okay, that's what we analyze as far as portfolio optimization is concerned. All right, good. Okay, next. So far, we used all returns, daily returns, weekly returns, monthly returns from your quant mode package for a univariate data. When we say univariate data, okay, for example, this one, Apple adjusted. We're just using this function for one data set, Apple adjusted. Now let's try this. Okay, I don't think I gave this to you. Okay, let me just share with you the text and then you write the code. All right. So as I said here, functions that we used above, the daily returns, weekly returns, monthly returns, all returns, are only for univariate data. Okay? Getting the returns of a portfolio of stocks will not give the returns of all assets. Okay, let's take a look at this. We have this object prices. And what does prices contain? Prices contain this is an XCS object. Okay, let me once again print this here. It's an XTS object, extensible time series. If I print this, it contains the adjusted prices of all the 9 assets that we downloaded. Okay. All right. What if I ask R to get the returns of these assets? So take a look at my function here. Take a look at the code that I generated. Okay, so I'm creating this object, returns, and I'm going to use the daily return, a daily return, a daily return function of quant mode, and then prices, and then type is equal to log. Okay, could you tell me, class, what happens? What results? What results into this? Kindly chat, please. Chat to me directly first. Do not chat to everybody. I'd like to know what you got as far as this function is concerned. We're asking R to compute for the daily log returns of the object prices. Prices contain several stock prices. So what did you get, class? Okay, I'm just getting one response. Okay, all right, let's wait for the others. Two responses only. Okay, okay. Daily returns of what? So some of you answered my question, the others have not yet answered my question. What is this, class? What is the you mentioned to me X number of columns. What are these? What object was generated by daily return of the object prices, which is an XTS containing 9 columns, which is 9 prices of the assets, portfolio of assets that we generated. Okay, if I print this, okay, you only have one, and you have 2014 entries. The prices data contain also 2014 prices. No? The returns object contain 2014 entries. Okay. Now the question is, what are these? Those are the daily returns of what? Portfolio. How? All stocks combined. All right. All stocks combined. So you have here the prices, diba? And then you only have one column. So what did it do with these prices? So I leave that to you, class, to discover what happened. But the result was, how did R generate this this one column of daily returns? How did it compute for that? And what I wanted to show you, class, that yung this function daily return will not work properly if you're using several data sets. This worked a while ago when we use Apple and then Apple adjusted, just for Apple adjusted. Okay. So how do we now construct? How do we now construct a data set where you have the returns only? Okay, enter now performance analytics, which is a very powerful package. So could you kindly, I'll just ask you to copy it and then install the package library, get the library of the performance analytics, because I know that we have already loaded this before. Okay, once you're done, kindly please inform me that you're done. Okay. Isa pa lang. How about the others? Let's wait for the others. Thank you, Jerome. Kindly load performance analytics. Dalawa pa lang, class? Okay, I hope everybody has loaded performance analytics. Okay. All right, let me show you what we can do with performance analytics. Okay. So here we can make use of this function return that calculate. So this is different from the quant mode function, daily return, okay, monthly return, weekly return. Here, this is coming from your performance analytics, and then we're using the return that calculate function. So here I'm generating the object stock returns. All right. Stock returns is the object, and then we're using the package performance analytics. Of course, it's okay to remove this, but I just wanted to show it to you so that you know what package this return that calculate is coming from. Okay, so what will be calculated? Okay, it's the object prices, and then we identified the method. The method is log, and then print this. Okay, I'll give you 1 minute, please, to generate stock returns, and please chat, class, kindly chat into the chat box to me only. Describe the data that you got. Describe stock returns. Okay, I got one answer. All right. Thank you, Jerome. How about the others? What did you get? If you run this stock returns using performance analytics, from the package performance analytics, you use the return that calculate function, and then define the object, and then the method that you're using. So I told you to use the log returns. Okay. Okay, so we have some more answers. All right. So I hope you got it, class. If we run this and create this object stock returns, let me. Okay, so I hope you got this, class, no? That's the one showing in my screen. We now have the returns of the log returns of each of the individual assets. Okay, so this is a lot more powerful than just using the daily return, the monthly return function, which is just for univariate time series data. In this case, the return that calculate can generate the returns for several assets. Yeah, thank you. You're correct, Christine, and the others. No? You were able to get it. Okay. So in this particular topic, we're going to download stock prices, and then we need to compute for the log returns. So this is a lot powerful compared to the quant mode package. Okay, because this can be used in order to calculate the returns of multivariate time series. Okay, so we just remove the first row because the first row is NA. Okay, let me just run this. And then my stock returns are now, okay, they do not contain any more the missing values there. Okay, there's another method that we want to discuss. And this is also a pretty powerful method. And it's an add-on to quant mode. Okay, so quant mode perhaps realized that they need to have a function that will calculate the returns of a portfolio of assets. So we come now to this method number 2. Now, for some reason or another, the first section had difficulty with this package, with this code. So if it doesn't work here, you can make use of the second one. So let me just share with you this code chunks. So you may wish to try. Oops, sorry. What happened? Okay, shut. All right, we're going to make use of a package, an add-on package. It's the quant mode add-on, QMAU. Okay, let me just call it QMAU. So for some, they were having problems about this because they couldn't load dev tools. Okay, but I think we loaded this before already, dev tools. So you can make use of this, or perhaps okay, here you can directly install the QMAU quick quant mode add-on from the repo, okay, in our project, and then library. So either or, okay, you may try doing this or doing this. But what's important is for us to be able to load quant mode. Since I already ran that a while ago, I will not anymore run that, and I'll check here, package quant mode add-on, and it's already checked, it's already installed in my case. So make sure that QMAO is installed and loaded in your computer. And I'll wait, class. Kindly please PM if you were able to already install and load the QMAO package. Once you're done, class, kindly chat, please. Right? Feedback, please. Were you able to? You can check here in your packages if QMAO is already loaded. Nobody has loaded it yet. Some students were having difficulty using this, so they just use this to directly load QMAO. Okay. All right. Thank you. So only two. How about the others, class, please? Kindly please chat if you have loaded the Quant Mode add-on. So this is an add-on package to Quant Mode, and it helps with additional features, additional functionalities with the Quant Mode package.
Sir, question lang.
Yes. Yes.
For your screen sharing po, sir, is it the G-Sheet po ba, sir, yung pinapakita niyo po right now?
Which one?
Or right now po, sir, yung naka-share screen po is yung Google Sheet po instead of, yes po.
Oh, wait. I'm now showing. Nakaano ba ako? Wait, Stop share.
Yes, sir.
Let me stop share. Wait. Let me share again. Share screen. How about this?
Ayan po, sir.
Okay.
Gumana.
Sorry. I think I paused sharing a while ago. No. All right. So I gave you this two code chunks, right? So these are two ways by which you can load, install, and load your QMA or your Quant Mode add-on. So for some of the students in the first class, they were having difficulty with this one. So I provided another way to load it. Okay. All right. So I hope you have and check class in here packages. You should see here QMAO. Okay. How about the others? I saw only two students saying that they have loaded QMAO. Others, please. Class, hello. How about the others? Are you encountering any problem, class? Okay, so dito may message si si Alvi. You might encounter a message like this. Control C. Okay. Our tools is required to build our packages, but it's not currently. Pag ganito class, then install our tools. Install the packages, our tools. Just follow what R is requiring. Downloading. Okay, how about the others class? You can try this. No? You can try this, install that packages, then repo is rproject.org. Okay, so we have another one done. Thank you. So let's give your classmates a few more seconds because we need the QMAO class. We need a functionality come from that package. Okay, waiting for the feedback of others, please. Tell me if you're encountering any problem. Did any one of you try this, the second one? Not via DevTools. Hello, class. Feedback, please. What happened to the others? I got only 3, 4, 5 feedbacks. What did you use, Joseph? What function? What code? Did you use the first one or the second one here? Second one dito. Okay, did you try the first one? This one? But you will have to install first DevTools and then try this. Okay, class, how about the others? How about Alvi? What happened to your case? Were you able to address the issue? Still the same. Okay, so I don't think we'll be able to resolve that now. Just kindly research, class, on you can Google, class, if you have problems with the quant mode add-on. I'm not sure why you're having difficulty with that, whether you use the first one or the second one. Anyway, I will I'll just discuss first what is the use of QMAO. All right, so let me just share with you this. Okay, let's see. Let me share this code chunk with you in the interest of time, class. I usually don't want to do this, but we're pressed for time. Okay. Is my screen still sharing, class?
Yes po, sir.
Okay. So let's discuss, class. I'm sorry for those who were not able to load their QMAO. Kindly just research on that. You should be able to, and make sure, please, to be able to load this. I'm sure there are many information in Google if there are any problems loading this. Okay. All right. Tingnan nyo na lang muna gagawin natin. Just take a look at what we're going to do. So the QMAO package allows us to make use of some functionalities, which is a shortcut to getting the prices or getting the returns from your of the assets that you're working on. Okay, here we have make price frame, which is equivalent to PF. So this is used when you have when you would want to create a data frame or a time series object that contains the adjusted prices, or it depends, open prices, high, low, close, etc. It depends on what you want. And then here, make price frame, or aka PF, you can use this or this one. And then when you're computing for the returns, you can make use of make return frame, or RF. Okay, so let's run this. Same thing, class. Let's make use of the tickers. Tickers. What's this object? Tickers. So the tickers contain our 9 assets, right? Apple, Google, Microsoft, up to S&P 500. Okay, so once again, let's create this object. Quant mode, get symbol stickers. Let's use another date, 2016, December 31 to 2021, December 31. Okay, daily, and then auto.assign is equal to true, which means that Excel will create an XCS object named Apple, Google, etc. Auto.assign is equal to true means automatically R will be the one, quant mode will be the one to assign the name of this object. And there will be, of course, we expect 9 objects. Okay, 9 objects of stock prices ranging from these dates, daily stock prices, okay, with names equal to the names in your ticker symbols. So if I run this, I will now generate here objects that contain here. Okay, so I now have here, okay, I now have Amazon, Google, GSPC, Intel, etc. Okay, so we now have those objects because we use get symbols, right? Okay, get symbols and then tickers. Or of course, you can, just like what we did a while ago, you can just define the tickers. You can just list C and then the stock prices. Okay, then what we're going to do now is take note your objects are separate. These are individual XTS objects. So you have an object for Amazon, Google, GSPC. If I print Amazon here, okay, so Amazon contains the open, high, low, close, diba? For Amazon. All right. Let me just go back here. Okay, so what I want to do is to merge the adjusted prices. A while ago, we used the do that call and then the merge. This time, we're going to make use of the QMOW function. There's a function there called make price frame. Okay, make price frame, and we identify what are the objects. So make price frame from Apple, from Google, from Microsoft, Intel, Amazon, Netflix, etc. Okay, so what will happen is that R will now create a frame, a data frame. So these are the dates, which are the same dates as the dates from Apple to GSPC, the dates that we used a while ago. And then we prefer the adjusted price. Okay, you can use, of course, here open, high, low, close, etc., or even the volume. And then na.omit is equal to true, silent is equal to true. And then let's view this object. So if I run this class, I run this. Okay, let me just share this code with you so that you don't have to write, because we're running out of time. That's the only reason. Otherwise, I would have wanted you to write the code yourself. Okay, there. So take note, class. Take note. There's an object called Apple, Google, Microsoft. These are separate objects. And then I'm using this make price frame. Okay, and make price frame, it will get the prices. Okay, and prefer is equal to adjusted, it will get the adjusted prices. So if I run this, I'm now able to generate this one. All right, so take note, from the individual stocks, Apple, Google, which consist of 6 columns, right? You have open, high, low, close. The QMA package was able to extract the adjusted price for Apple up to GSPC. Okay, let me pause for a while and ask you if you were able to generate that. generate this object making use of the make price frame. Okay, good. Thank you, Jerome. Let's wait for the others to key in their feedback. Okay, thank you, Vince. Yeah, Rigel, thank you. Of course, class, you should have been able to already load QMAO. For those of you who were not able to load it, very sorry about that, but just copy the codes, class, and then work on that on your own. Okay, thank you, Alvi. All right, may I ask you, class, a while ago, how did we create uh, this the object containing the adjusted prices? I think we used the prices data, right? This one, this one. Okay, it's the same as the RF, the price frame object. The same. It's the same thing. Okay, but for you, what do you think is easier? When we generated the prices object using the L apply first, and then another L apply, and then another do that call merge, as compared to here we just download first the prices, the assets using the get symbols, and then just use the QMAO package and then make price frame for us to extract all the adjusted prices from each of these objects. For you, what's easier? What do you prefer to use? Okay, thank you, Jerome. How about the others? You can please share your when you answer. Please share it with everybody. All right. So I think everybody will say, especially those of you who are able to use the QMAO package, that this is a lot easier. Okay, or you can replace this make price frame with just the PF function. Okay, this will be the same class, PF function. Okay, so you just copy everything and just change this. You change the make price frame into PF function. So this is the shortcut, price frame. And if you run this, okay, I use another name, PF1, just to make sure that I preserve the PF object. And please chat, comment please if you were able to get the same object as the make price frame function. Okay, I'll wait for your chat and confirmation if you got the same thing. Okay, thank you, Vince. How about the others? Okay, Raul, thank you. Christine, thank you. Okay, Abby, thank you. All right, I hope the others are able to follow. Okay, thank you, Jerome. All right, so same thing, class. And the it's actually a shortcut function, PF, yung isa naman, make price frame, ano? Yan, make price frame, that one. All right, then that's not all, class. That's not all. You can also directly just get the returns. Okay, instead of, you can dispense with, if you don't need actually the prices, then just get the returns. If you're just working on the returns, why not just go directly to the returns? Okay, so here, I'm just changing the function, make it make return frame. Okay, make it make return frame, and then just follow everything except for, okay, we're just going to add this type is equal to. Since we're now computing for the returns, you have to identify whether this is discrete returns or the arithmetic returns or the continuous, which is the log returns. Okay, so we just added this to define what returns would we want to generate. So everything is the same. Make return frame, just change the make price frame into a make return frame. And then tell me, class, here I'm generating an object called RF. Okay, RF. So tell me what are you able to generate? Waiting for your response, class. Actually, you're just going to copy the code above, and then just add this. Of course, change the function, and then include here type is equal to continuous. Continuous is your log returns. What did you get, class? Okay, yes. Thank you, Jerome. How about the others? Waiting for the feedback of others, please. All right, thank you. Yeah, thank you. Sabi ni Vince na it gives us the log returns of the of all the stocks. Kaso may NA siya, no? So that's why we will have, of course, to delete the missing value at the start. That was expected kasi walang we'll have an NA value really there, a missing value there. Okay. All right. So here we just remove the missing value, the first column, or you can make use of the RF function. Same thing. A while ago, you made use of the PF function. Here, instead of make return frame, you can use the RF function. Same thing. You'll generate the same answer. Okay. All right. Okay. Please tell me if you got the same answer, class. RF. This one. And then remove the first row again. All right. Thank you, Abby. Okay. So did the RF and the make return frame function give you the same answers? Okay, thank you. So the same answer, class. The same answer. So you have two options: make price frame. Okay, you may do that, class, if you really need the XTS objects containing the prices. But if you're working with portfolios, we might not need those anymore. But it doesn't matter, class, if you also generate that, because maybe later on you might need the prices. But for portfolio optimization, what we need is the returns. So just to quickly summarize, how do we get the returns of your portfolio of assets? Very easy, class. Make use of the quant mode package. Okay, get symbols, identify the different assets that you'd like to download, and then you can make use of the QMAO package, where you can use the RF if you want to generate the returns. Okay, you can identify if it's discrete, which is arithmetic returns, or if it's log returns, then use continuous. And then there you go, finish, class. So very fast, very convenient and very efficient way to at least compute for the returns. All right. So next meeting class, we're going to compute now. Okay, we're going to learn how to compute for the portfolio returns. Okay, because what we have there are just the returns of the individual assets. Okay. So next meeting, we're going to learn how to compute for the portfolio returns, and we're going now to start learning how to create the optimal portfolio, either based on the maximum returns or the um, uh, minimum risk. Okay, so we're going to do that, and then we're going to learn rebalancing also. All right, so what is due me, class, is the recording of Garch. Okay, I'm going to post the recording of Garch. Okay, I'm uh, I'm thinking of I'm thinking of either a multi. I'm really tempted to make you do a multivariate Garch, because Garch, for Garch, you're just going to model each individual asset. But if it's multivariate Garch, then you'll have to look at the all the assets as one, and then generate a Garch model for those for that uh, multi number of multi assets. Okay, I have to decide on that and announce it uh, through Canvas. All right, so that will be all for today. We were able to cover our lesson. So next meeting, we hope to be able to finish everything here. Okay, I'll mhm. Should I? No, not yet. Maybe not yet. I'll just discuss this next meeting. All right. So let's end here, class, and then we will uh, we will of course meet on Tuesday next, face to face in person again. All right. Thank you so much, and have a blessed break ahead. Although it will not be necessarily a break because I'll still post some videos for you to. I hope you watch the videos. Okay. All right. So I'll see you. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you po.
Thank you.
Thank
Thank
you,
you.
sir.
All right. Thank you.
Bye, sir.
Bye-bye. O nga, no, next month na, Abi. O nga pala, next month na. See you next month, everyone.